So in this video we're just going to go through some of the resources, practice questions and also answers for the alkenes topic. This is for the OCR A-level specification. So if you'd like a summary sheet, this you can download by following the link at the bottom there, and it just highlights the key areas you need to know for this area. And also to test your understanding, this is an alkenes quiz. This just will test your knowledge of the topic, and the following page, the alkenes exam style questions, that test more your understanding and application of this topic. And we're now going to go through the answers, so hold off. You can download both those by just following those links. Have a go at those and see how you get on. So first of all, we'll go through the quiz. So again, this is just to test your knowledge and a little bit of application as well. So we've got propene, so we're just doing some general formulae there, the molecular, structural, displayed and skeletal. Bonding between the two carbon atoms, this is one you need to really know, that it is a pi bond and a sigma bond, and you need to know what a pi bond and sigma bond is. Describe the shape of the ethene molecule, so we've drawn the ethene molecule there. It is of course trigonal planar around each of those carbon atoms because you've got 3 bonding pairs. I'm sure you remember from the first module that you started that in terms of shapes of molecules you count your double bond as one area of electron density. So you've got 3 there, no lone pairs, so each of those bond angles that we have around there is 120 degrees. And of course the test for an alkene is bromine water turning colourless when added to an alkene. So we've got some of the equations now, so some of the routes you can use for synthesis for alkenes. First of all, reacting with hydrogen, of course you'll just make the alkane, and you need nickel gases for that. If you react propene with steam, you will of course make 2 products, propan-1-ol and propan-2-ol, because of the way that the OH and the H can add. This is of course your major product because the H will add to the carbon which already has the majority of hydrogens attached. We need phosphoric acid for that reaction to work, and then we're just going to use the reaction of ethene with hydrogen chloride as a route, and then we're going to look at ethene reacting with chlorine to give 1,2-dichloroethane. That's of course electrophilic addition, and we've got the equation there. So part C, we need a mechanism for electrophilic addition. So that's shown as there. So what you need to remember to add for this one is you need of course your arrow going to the Cl delta plus. You need your Cl delta plus and Cl delta minus on your chlorine-chlorine double bond. You need the chlorine-chlorine bond breaking. You need to get your intermediate correct, your carbocation there, and with your final curly arrow going from the chloride to the carbon positive. Cl2 is of course the electrophile because it is an electron pair acceptor, and there you have the polymerization of fluoroethene, and that molecule is of course polyfluoroethene. Don't forget as well, to get the marks obviously you need to get that product correct, and you also need to remember to put the ends at the beginning of the equation there, because we're not sure how many we've got, which will make a polymer of n length. Okay, the next one looks a bit tricky, but we'll try and just work this out as we go along. So I've drawn cyclohexene there. What I'm going to do is I'm just going to show you how we do this. So I would draw that same molecule, which I've done, but rotate it by 90 degrees. So you've got what was a double bond at the top there. Okay, and then all you're going to do is make that into a polymer. So the way you do that is you pop in your extended polymer bonds like so, put your square brackets around and make it of n length like so. I know it doesn't look pretty, but it's right and it will get you the marks. And that is of course named polycyclohexene. So through the alkenes exam style questions. So these are slightly more difficult, but hopefully you've built up your knowledge now that you can do these successfully. So we have got cyclopentene there, and this is a typical exam style question that rather than giving you a simple alkene like ethene, they put it into a cyclic compound. So first of all, what happens when you add hydrogen? Exactly the same as before, you just get rid of the double bond like so. And when you add bromine, you just add bromine across the double bond. So just draw the molecule out and then make the changes as you would. Um, what are the reagents conditions needed for 3? Well, you can see you are adding H there and an OH there. So you need steam and a phosphoric acid catalyst. The product there is cyclopentanol. You may not have studied alcohols yet, so not be able to name that, but that's how you would call it. And what would be the colour change? It would go from orange or brown to colourless. So we're moving on to question 2, which is about polymers. So we are polymerizing butyronine. So draw butyronine as I've done there, and then redraw it without the double bond for the product here. But either side of those carbons, you put in the extensions there of the polymer. Oh, a name for the monomer. Well, if you have a look at the monomer, this is your repeating unit there. So if you just draw that out, but then put a double bond in, so CC, it'll be H, double bond there, OH, and an H there. The name suggests the monomer, or that would be the monomer there. Why would it be soluble? It's because it's got OH groups, around, and of course they can form hydrogen bonds with water molecules. Okay, so question 3 then. We've got to name that alkene. They made it a bit trickier because we're in skeletal formulae again now. So what's my longest chain? Well, my longest chain is 4 carbons, like so. So it's going to be bute. On that second carbon there is the double bond, so it's butene. And also on that second carbon, you've got a methyl group, so it's methyl butene. You don't need to put 2-methyl butene because if you've got a methyl group, it's got to be on that second carbon. Type of mechanism for that reacting with hydrogen chloride is electrophilic addition, and there's a mechanism shown there. You are going to have your arrow going from the double bond to your delta plus hydrogen, and don't forget you've got delta minus chlorine there. Your arrow there of the electron pair going to chlorine to form chloride, which then adds to that carbocation there. Why is this a major product? Well, it's a major product because the hydrogen added to the carbon with the most hydrogens already attached, and the reason it did that is because the intermediate tertiary carbocation, which is formed here, is more stable than a secondary carbocation, which would have been formed on this carbon there had the other product been produced. Name the minor product formed. Well, the minor product would have the chlorine on that one, so it would be 2-chloro-3-methyl butane. So here are your other possibilities that have molecular formulas C6H12 that show EZ isomerism. For them to show EZ isomerism, remember that you need different groups on those carbons with a double bond attached. So you couldn't have this example as showing EZ isomerism because it wouldn't matter about these two hydrogens, which way they go, because it's the same atom. Is this the E or the Z isomer? Well, for that we look for the atom attached to the carbon with a double bond with the highest atomic number, in which case that's going to be fluorine and it's going to be chlorine either side. They are then on opposite sides of the double bond from each other, and therefore it is the E isomer. And you can just explain that using the atomic numbers. Why can this molecule not be labelled as either cis or trans? Well, to call a molecule cis or trans, on the 2 carbons with the double bond, they have to have H's like so. So each one has to have an H because you're actually referring to the positions of those H's. So for example, these are the 2 that you could have, in which case this one here would be called cis, and that will be called trans because you are merely referring to the position of the H's. So that's it for the alkenes topic. I hope you found that useful. And as with all of these topics, practice those exam style questions that will really help you.